3I-ATLAS was discovered on July 1st by the NASA-funded ATLAS survey.
Harvard astrophysicist Avi Loeb has suggested the 3I-ATLAS is actually some type of alien technology sent here from another solar system.
In 2017, humanity encountered a strange visitor from deep interstellar space, the object known as Oumuamua. At the time, no one realized what it truly was. It came from another star system, moved in ways no known asteroid or comet should move, and left behind more questions than answers. For years, scientists have tried to understand it. Now, in 2025, something even more extraordinary is happening. Another interstellar object, designated 3I-ATLAS, is speeding toward the inner solar system, and new analyses from Harvard University and NASA suggest that it may be on a trajectory that could lead to a direct impact with the moon. It is not a confirmed impact, but it is a real possibility, one that has captured global attention. Interstellar objects are incredibly rare. For most of human history, we didn't know for sure that any had passed through our solar system. Then, in the span of only a few years, 3 have arrived. Oumuamua in 2017, comet Borisov in 2019, and now 3I-ATLAS in 2025. Each one has been unique, but 3I-ATLAS stands out in dramatic fashion. Not only is it massive and extremely fast, but its path is unlike anything scientists expected. Initial projections showed a harmless flyby. Updated trajectory data, however, now point to the possibility that the object could collide with the moon, an event unlike anything modern astronomy has ever witnessed. The moon has been struck countless times across billions of years. Its cratered surface tells the story of ancient impacts from asteroids and comets born in our own solar system. But 3I-ATLAS is different. It comes from another star system entirely, carrying with it minerals, ice, and dust that formed under conditions alien to our own. If it hits the moon, it wouldn't just carve a new crater. It would deliver material literally from another part of the galaxy. It would be the cosmic equivalent of a sealed time capsule traveling for millions or billions of years, finally breaking open on impact. Early analyses estimate that the nucleus of 3I-ATLAS could be up to 10 or 11 kilometers wide, surrounded by a coma that makes the entire object appear as large as 20 kilometers across. This makes it far larger than either Oumuamua or Borisov and significantly more energetic. Because the moon has no atmosphere, 3I-ATLAS would hit the lunar surface completely intact, with no air resistance to slow it down or break it apart. It would strike the surface at interstellar velocity, releasing more energy in a single moment than any human civilization has ever witnessed directly. Depending on the impact location, the explosion could send a plume of debris hundreds of kilometers high, potentially visible from Earth with the naked eye. Even if the impact occurred on the far side of the moon, the seismic shock would be detected by instruments left there from past missions, allowing scientists to watch the moon ring from the blow. Despite the dramatic imagery this event conjures, Earth itself is not in danger. The moon is too massive and too distant for such an impact to destabilize its orbit or threaten Earth with falling debris. However, the collision could subtly alter the moon's internal structure, rearrange mass deep beneath its crust, and create a new geological feature that would become a landmark for future lunar exploration. For upcoming missions, including planned crewed bases and robotic operations, the new crater could reshape scientific priorities and mapping systems, influencing where spacecraft land, where rovers travel, and where researchers choose to investigate. For scientists, a 3I-ATLAS collision represents an unprecedented opportunity. The idea of being able to analyze the aftermath of an interstellar impact in real time is something that planetary scientists could only dream of until now. The materials buried inside 3I-ATLAS would be unlike anything found on Earth or the moon. They may contain frozen gases that reveal chemical fingerprints of long-dead stars, minerals that form only in exotic temperature ranges, or isotopes that could reveal the age and birthplace of the object. Lunar orbiters, telescopes on Earth, and potentially even landers could monitor the event as it unfolds, gathering data across every spectrum of light. What 3I-ATLAS contains might help scientists understand how other planetary systems form, evolve, and die, offering a window into the broader mechanics of our galaxy. But this event also raises an unsettling question. If 3I-ATLAS were headed toward Earth instead of the moon, Would we have been able to stop it? The answer right now is no. Traditional planetary defense strategies, like kinetic impactors or gravity tractors, are designed for objects that follow slow, predictable orbits around the sun. Interstellar objects are different. They arrive suddenly, move incredibly fast, and leave little time for preparation. 3I-ATLAS highlights a category of cosmic hazard that humanity is not yet fully equipped to defend against. NASA and Harvard researchers have emphasized the need for improved early warning systems and new technologies capable of responding to fast-moving objects from outside the solar system. Even though launching a new mission to intercept 3I-ATLAS is impossible with current timelines, NASA has explored whether existing spacecraft, such as orbiters around Mars or the Juno probe near Jupiter, could adjust their paths to observe or pass near the object. While such missions would be challenging, even a partial intercept could provide valuable data. Observing an interstellar object up close, even briefly, would be one of the most important scientific achievements of our generation. Beyond science and engineering, the psychological and cultural effects of such an impact would be enormous. For thousands of years, the moon has been a symbol of stability, a calm, unchanging presence in the night sky. To witness a massive explosion on its surface would be a reminder that nothing in the universe is truly permanent or immune to cosmic events. A new crater, visible for centuries to come, would become a permanent marker of the night when an alien visitor struck our nearest celestial neighbor. It would influence culture, art, storytelling, and imagination around the world. Just as great comets and eclipses have shaped myths and beliefs throughout history. From an exploration perspective, the impact would reshape lunar priorities. Countries and companies working toward establishing lunar bases would likely redirect missions to study the new crater. Freshly exposed subsurface material would be of immense scientific interest. The possibility of discovering exotic interstellar minerals or compounds could spark a wave of investment in international collaboration unlike anything since the Apollo era. The moon, already viewed as a strategic stepping stone to Mars and the outer solar system, would gain even more importance as a natural laboratory for studying materials and processes from beyond our solar system. The impact would also transform education and public engagement. Teachers would be able to point to actual live footage or measurements of a major impact on the moon, using it to explain gravity, orbital mechanics, geology, and the nature of interstellar objects. Students would grow up knowing that they lived during a rare cosmic event, one that reshaped the moon's face. Planetariums, museums, and science centers would create exhibits dedicated to understanding the collision, and documentary filmmakers would record the event from every angle. Much like the Apollo landings, this event could inspire a new generation of scientists, engineers, and explorers. On a global scale, the scientific collaboration surrounding 3I-ATLAS would highlight how interconnected modern astronomy has become. Observatories, satellites, universities, and space agencies around the world have each contributed to refining the object's trajectory. This event underscores the importance of international cooperation in monitoring the cosmos, especially as more interstellar objects may pass through our solar system in the future. Even with all of these predictions and models, uncertainties remain. The cosmos is unpredictable, and small changes in 3I-ATLAS's speed or path could alter the final outcome. This mix of knowledge and uncertainty adds tension to the unfolding story as researchers and the public wait to see what will happen. If you enjoyed this video, be sure to like and subscribe. And let us know in the comments what you think about the possibility of 3I-ATLAS hitting the moon. We'd love to hear your thoughts. Thank you for watching, and see you next time.